Hi, in this video we are going to discuss valence bond theory and complex formation. In the previous videos we have discussed valence bond theory on the base of atomic orbital and quantum mechanics, and hybridization, which is the extension of valence bond theory. Valence bond theory and complex formation was developed by Linus Pauling. According to this theory, these are the empty orbitals of metals or ions. These empty orbitals of metals or ions mix and form equal number of empty orbitals, having same energy and shapes. These equivalent orbitals are also known as hybrid orbitals. These hybrid empty orbitals of metal decide the coordination number. In fact, the number of empty hybrid orbitals are equal to coordination number. Coordination number. This is actually the number of the bonds which the central atom form with the ligands. And after hybridization, these empty hybrid orbitals of metals overlap with the filled orbitals of ligand. Here ligand we say that any species which donate electrons are called ligands. And as the empty hybrid orbitals overlap with the filled orbitals of ligand, they form sigma bond or coordinate covalent bonds. In valence bond theory, we have discussed these are the half-filled atomic orbitals which overlap and form covalent bonds. But here, these are the empty hybrid orbitals of metals which overlap with the filled orbitals and form coordinate covalent bond. Here in valence bond theory and complex formation, we can say these are the empty hybrid orbitals which are equal to coordination number or coordinate covalent bonds. For example, in coordination number 6 molecules, the central atoms have 6 empty hybrid orbitals or 6 covalent bonds, which are coordinate covalent bonds. And in coordination number 6, molecules have two types of hybridization. This is the hybridization which decide the geometry and magnetic properties of molecules. In coordination number 6, molecules have d2sp3 hybridization and sp3d2 hybridization. In d2sp3 hybridization, 1s3p and 2d orbitals, which are inner orbital dz², dx², y². These orbitals mix and form equal 6 number of hybrid orbitals. For example, complex of cobalt with ammonia and complex of chromium with cyanide. These are the molecules which are the example of coordination number 6, and here the central atoms are d2sp3 hybridized. When we see the electronic configuration of cobalt, which has 27 electrons or atomic number, This has 7 electrons in 3d, 2 electrons in 4s, and empty 4p4d orbitals. And after ionization or losing 3 electrons, this has 6 electrons in 3d orbitals or empty 4s 4p4d orbitals. This has outer d orbitals which is 4d orbital. This do not involve in this type of hybridization. But here inner d orbital which is 3d orbital involved in this type of hybridization. And when ammonia, which is a strong ligand, approach to this metal or ions, push the electrons in 3d orbitals. So electrons in 3d orbitals are paired. After that, 2 orbitals in 3d are empty, which are dz², dx², y², and available for hybridization. And after that, 2d orbitals in 3d which are dz², dx², y², 1s orbitals of 4s and 3p orbitals of 4p. These orbitals mix or hybridize and form d²sp3 6 hybridized orbitals which have the same energy and same shapes. Now in these d²sp3 hybridized empty orbitals, 6 ammonia molecules donate their electrons and form coordinate covalent bonds or form cobalt complex with ammonia. And the charge on complex is the sum of metals ion or ligand, as here cobalt has +3 charge and ammonia is a neutral, so the charge on this complex is +3. So we can say this is strong ligand which form d²sp3 hybridization. As strong ligand push the electrons in 3d or electrons are paired up. No, electrons have spins but opposite. So molecules behave diamagnetic or have low spin. And these complexes are also called inner complex as inner d orbital which is 3d involved in this type of hybridization, not the outer orbital which is 4d. This is cobalt which is d²sp3 hybridized or has 6 d²sp3 hybrid orbitals. These empty hybrid orbitals overlap with the filled orbitals of ligand or ammonia molecules and form sigma or coordinate covalent bonds. The net charge on this complex is +3, as we have discussed. We can also represent this complex in this way, as the central metal ion forms 6 coordinate covalent bond with 6 ammonia molecules and form the geometry octahedral, as we have discussed in Valence Bond theory, and the bond angle here is 90 degree. Coordination number 6 molecules are also have sp3d2 hybridization, in which 1s 3p 2d orbitals, which are outer orbitals dz², dx², y² involved. For example, in cobalt fluoride complex and chromium fluoride complex. Here the central atoms are sp3d2 hybridize. This is the electronic configuration of cobalt ion as we have discussed, which has 6 electrons in 3D and empty 4s4p and 4d orbitals. In this type of hybridization, 4d orbitals are involved, not 3d orbitals which are involved in d2sp3 hybridization. As fluoride is a weak ligand which do not push the electrons in 3D, so electrons in the 3D orbitals remain unpaired. So 4s4p and 4d orbitals mix or hybridize and form 6 empty sp3d2 hybridized orbitals. Here in 3D orbitals, there are 4 electrons which are unpaired. And in empty sp3d2 hybridized orbitals, 6 fluoride donate their electrons and form coordinate covalent bond or form cobalt complex with fluoride. And here the net charge is the sum of the metal ions or ligands, as the cobalt has +3 and each fluoride has 1 negative charge. So here the net charge is -3. So we can say this is the weak ligand which form sp3d2 hybridization, in which electrons remain unpaired, or molecules behave paramagnetic or have high spin. And these molecules are also called as outer complex, as outer d orbitals from 4d orbitals are involved in this type of hybridization. Here this is cobalt which is sp3d2 hybridized, having 6 empty hybridized orbitals which overlap with the filled orbitals of fluoride ions and form 6 coordinate covalent bond. Here the net charge is -3 as we have discussed. We can also represent this molecule in this way, as the central metal ions form 6 coordinate covalent bond with fluoride ions having net -3 charge. In this way, cobalt form complex with fluoride, and the geometry of this molecule is also octahedral, which having the bond angle 90 degree. And in coordination number 4 molecules, here the central atoms have 4 empty hybrid orbitals or 4 coordinate covalent bonds. And in coordination number 4 molecules again have 2 types of hybridization. And this is the hybridization which decide the geometry and magnetic properties of molecules. Here molecules have sp3 and dsp2 hybridization. In sp3 hybridization, 1s and 3p orbitals involved. For example, nickel chloride complex, nickel carbonyl complex, and zinc ammonia complex are the example of coordination number 4 molecules, and here the central atoms are sp3 hybridized. This is the electronic configuration of nickel, which has 28 electrons and 8 electrons in 3d orbitals, 2 electrons in 4s and empty 4p orbitals. And after ionization or losing 2 electrons, this has 8 electrons in 3d orbitals and empty 4s and 4p orbitals. And as the colloid ions approach to this ions, which is a weak ligand, and the weak ligand do not push electrons, so the electrons remain unpaired in d orbitals. So here 4s and the 4p orbitals are available to hybridization. So these orbitals hybridize and form 4sp3 hybridized empty orbitals. And here nickel has 2 unpaired electrons in 3d orbital. In sp3 empty hybrid orbitals, colloid ions donate their electrons and form coordinate covalent bonds or nickel colloid complex. Here the complex has -2 charge. This is because nickel has +2 and each colloid ion has -1. This is nickel ion, which is sp3 hybridized or having 4 empty hybridized orbitals which overlap with the filled orbitals of colloid ions and form coordinate covalent bond. And here the net charge is -2. And we can also represent this molecule in this way, as the nickel ion form 4 coordinate covalent bond with 4 colloid ions. And the net charge is also here -2. The geometry of this molecule is tetrahedral, which having the bond angle 109.5 degree. In nickel carbonyl complex and the complex of second B metals zinc, cadmium and mercury, these complexes also have sp3 hybridization in coordination number 4. Here nickel has oxidation number 0 and zinc, cadmium, mercury have oxidation number +2. In these complexes, the central atoms have filled d orbitals or paired electrons. So these complexes behave diamagnetic. And in nickel colloid complex, which also has sp3 hybridization, but this complex has 2 unpaired electrons. So this behave paramagnetic. And in coordination number 4, molecules also have dsp2 hybridization, in which one s, 2p and one d orbital which is the x² y² involved. For example, in nickel cyanide and copper or cobalt complex with strong ligand, here the central atoms are dsp2 hybridized. This is the electronic configuration of nickel ion as we have discussed, which has 8 electrons in 3d orbitals and having empty 4s and 4p orbitals. And as the cyanide ion approach to this ion, which is a strong ligand, and the strong ligand push the electrons or paired of the electrons in d orbitals. So this ligand pushed the electrons in 3d orbitals or paired the electrons in 3d orbitals and make empty or available 1d orbital for hybridization. So one orbital from 3d, one orbital from 4s and two orbital from 4p. These orbitals mix or hybridize and form 4 dsp2 hybridized empty orbitals. Here the nickel ions has 8 electrons in 3d orbitals which are paired. And in each empty dsp3 hybridized orbitals, cyanide donate their electrons and form coordinate covalent bond. In this way nickel form complex with cyanide, which having the net charge -2. This is because nickel has +2 and each cyanide has -1. And as there is no unpaired electron, this molecule behave like diamagnetic. This is nickel ion which is dsp2 hybridized or having 4 dsp2 hybridized empty orbitals. These orbitals overlap with the 4 cyanide ions or form 4 coordinate covalent bond. And here the net charge is -2. We can also represent this molecule in this way, as here the nickel ion form 4 coordinate covalent bond with 4 cyanide and the net charge is also here -2. The geometry of this molecule is secure planar. Thanks for watching and please comment if you have any question.